Chunk search often finds the right clue, but returns the wrong amount of context. Parent document retrieval fixes that by searching small and returning bigger. You'll understand the pattern behind a pipeline that slices recall-worthy chunks and lifts full parent passages for answers. I'm Professor Pi, teaching search and IR with simple Python. Parent document retrieval with Chroma solves a common pain in retrieval systems. Tiny chunks are fast and precise, but they rarely carry the whole story you need to answer or quote. Chunk-level search points you to the relevant slice. Parents give you the authoritative passage. Engineers reach for this when embeddings and vector search are cheap for short text. But answers should come from a canonical source. Success looks like consistently finding the right snippet and then mapping it back to its original document. That reduces hallucination and gives you a single document to cite. Chroma is handy here because it stores vectors, metadata, and arbitrary document fields in one place. No extra join across two databases. The pattern is straightforward. Break big docs into small chunks and index those as vectors. Keep a separate collection of whole parent documents. When a query hits a chunk, use that chunk's metadata to look up and return the full parent text. You get precision from the chunk and completeness from the parent. The trade-off is the extra lookup latency, but you control it by limiting how many parents you hydrate. Concretely, imagine two guide documents, each split into 3 short lines. Index those lines as children, and keep the 2 full guides as parents. A search might return a child ID like guide 0, and then you fetch the guide parent to read the full guidance. That's the pattern we'll build. We will implement a toy pipeline that loads parents, inserts child chunks with parent pointers, queries chunks, then hydrates parents. The goal is teaching the full flow so you can apply it to documentation search, or RAG. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we load canonical parent documents into Chroma, so later lookups return a trustworthy source. This snippet seeds Chroma with parent documents ready for later lookups. Engineers often worry about keeping canonical copies of source docs, so chunk recall still points somewhere trustworthy. We spin up chromadb client and call parent_call.upsert, so the deploy guide and FAQ sit inside a dedicated parent docs collection. Because these summaries mention ingest flows, SLA gates, and cache policies, they already encode the holistic guidance chunks rarely carry. Seeing parents loaded equals 2 confirms the parent shelf is stocked for downstream retrieval. Next, we create small searchable chunks and link them back to parents so short hits keep the breadcrumb trail. This example leaks child embeddings into the Chroma chunk index alongside parent references. The question is how to keep high recall slices tiny without losing the breadcrumb trail back to their source document. By packing tuples in rows, we pass concise documents, deterministic toy embeddings, and the crucial parent ID plus order metadata into Chunkajalo upsert. Manual embeddings keep the tutorial offline friendly while still respecting Chroma's need for consistent vector dimensions. The chunk count equals 3. Output verifies that every parent now has searchable children to work with. Now, we query the chunk index to inspect what raw recall returns and see how skinny a chunk can be. This snippet queries Chroma for the top chunk hits so we can inspect what recall returns. The practical worry is whether a retrieved slice exposes enough context to drive a ranked answer. Chunk call query runs on our manual embedding, and because results are batched, we index the first row to grab IDs, metadata, and documents directly. Splitting on the semicolon keeps the excerpt honest, while still showing how short the raw chunk really is. The printout demonstrates that chunk guide 0 maps to parent guide, yet only surfaces a single clause. Then, we hydrate the parent records for any returned parent IDs, so we regain the full context we need to answer or cite. This snippet pivots from chunk hits to parent records to measure context regained from Chroma. The key decision is how many parent documents to hydrate once a query returns multiple children across collections. We build an ordered set of parent ID values, run parent_call.get, and zip IDs with documents to restore full texts. Counting words is a quick health check, showing exactly how much richer the parent payload is than the skinny child clause. The parent context words output confirms both parent docs are available with double-digit token budgets. Finally, we wrap the pattern into a helper that issues chunk queries and fetches parents in arrival order for deterministic context. This example wraps the Chroma workflow into a helper that returns both chunk hits and parent contexts. Engineers usually ask how to keep parent lookups deterministic while still limiting payload size per query. Retrieve with parents issues chunk_call.query, deduplicates parent IDs in arrival order, and fetches the matching documents via parent_call.get. Adjusting chunk top increases recall breadth, while a smaller max parents keeps responses lean if you only want one document per answer. The final print shows we currently pocket one parent context alongside the winning child chunk, proving the loop is RAG ready. To map this toy example to a real system, replace the manual embeddings with your chosen encoder and the small in-memory Chroma instance with a persistent store. In production, you will tune how you slice text, whether you include overlap, and how many parents you fetch per query. A quick wrap. This is a two-stage retrieval pattern. Search compact chunks for precision, then fetch full parent documents for authoritative context. Use it when you need both pinpoint hits and source text you can quote or summarize. The trade-off is extra latency for parent hydration. So pick how many parents to fetch with that cost in mind. Next step, tune how many chunk hits you request per query by increasing chunk top to broaden recall or reduce max parents to control payload size. That single knob often changes precision and latency in predictable ways. If short, practical IR helps, subscribe and watch the IR videos.